Welcome everyone. Today we are starting one of the most important chapters in chemistry, that is basic concepts of chemistry. Think of this chapter as the foundation stone of entire subject. Just like you cannot build a house without a stone base. Similarly, you cannot understand chemistry without mastering these ideas. In this chapter, we will learn what matter is, how substances combine, how chemists count atoms using the mole concept, and how calculations are done in chemical reactions. These ideas may look simple, but they are used everywhere, starting from medicines to industries and to environmental science. Let us first look at what this chapter covers. We begin by understanding the nature and classification of matter. In simple words, what things are made up of and how we group them. Then we move to the laws of chemical combination, which are like the rules that all chemical reaction must follow. Next comes the mole concept, which is the heart of this chapter. It helps us count atoms and molecules that are too small to see. Finally, we apply these ideas in stoichiometry, where we calculate how much reactant is needed and how much product is formed. These ideas are not just theoretical, but they are used in real life, which we will also discuss. Matter is anything that has mass and occupies space. If you touch it, weigh it, or see it, then it is matter. A book, air, water, even your body are all matters. Matter exists mainly in three states: solid, liquid, and gases. Solids have a fixed shape and volume, like a table. Liquids have a fixed volume but no fixed shape, like water in a bottle. Gases have neither fixed shape nor volume, like air. Understanding matter helps us explain why ice melts, water flows, and gases spread everywhere. Matter can be classified into pure substances and mixtures. Pure substances have a fixed composition. For example, pure gold or pure water always have the same properties. These are further divided into elements and compounds. Elements contain only one type of atom, while compounds contain different atoms combined in a fixed ratio. Mixtures contain two or more substances mixed in any proportion. Air is a homogeneous mixture because it looks uniform. Sand mixed with salt is an heterogeneous mixture because we can see different parts in that mixture. This classification helps chemists decide how to separate substances and study their properties. Laws of chemical combination. These laws are the rules of chemistry. They tell us how substances behave during reactions. The law of conservation of mass says that matter is neither created nor destroyed. Imagine cooking. The ingredients you add change form, but nothing disappears. The law of definite proportions tells us that a compound always contains elements in the same ratio by mass. For example, water is always H2O. It doesn't matter whether it is liquid, vapor, or ice. It is always H2O. The law of multiple proportions explains why the same elements can form different compounds. like carbon monoxide and carbon dioxide. So both are made up of carbon and oxygen, but carbon monoxide is CO, whereas carbon dioxide is CO2. These laws prove that chemistry is not random, but it is systematic and predictable. The mole concept is the most important part of this chemistry chapter. Atoms are extremely small, so we cannot count them one by one. It is very difficult. It is not possible also. A mole is a counting unit, just like a dozen banana means 12 banana. There similarly, one mole means it contains 6.022 into 10 to the power of 23 particles, which is also called as Avogadro number. Why such a huge number? Because atoms are incredibly tiny. Using the mole concept allows chemists to connect the microscopic world of atoms to the macroscopic world of gram and kilogram. Molar mass is the mass of 1 mole of substance expressed in gram per mole. For example, 1 mole of carbon weighs 12 grams. 1 mole of water weighs 18 grams. What does it mean? That means 12 gram of carbon contains Avogadro number of water molecules, carbon molecules. Similarly, 18 gram of water contains Avogadro number of water molecules. This is extremely useful because it allows us to convert between mass and number of particles. In real life, this is how medicines are dosed accurately and chemicals are manufactured safely. Stoichiometry deals with quantitative calculations in chemistry. It answers questions like how much reactant is needed, how much product will be formed. Think of it like cooking. If a recipe needs 2 cups of rice for 4 people, you can calculate how much is needed for 10 people. Similarly, in chemistry, we do the same using balanced chemical equations. Stoichiometry ensures efficiency, safety, and cost control in chemical reactions. The limiting reagent is the reactant that gets completely used up first. Imagine making sandwiches. If you have plenty of bread but only 2 slices of cheese, then cheese becomes the limiting ingredient. Similarly, in a chemical reaction, the limiting reagent decides how much product can be formed. Identifying it correctly is crucial for solving numerical problems and for industrial production. These concepts are not just for exams, but they are used everywhere. In medicine, correct mole calculations ensure safe drug dosages. In industries, stoichiometry helps avoid wastage and save money. In environmental science, chemical calculations help control pollution and greenhouse gases. Every fertilizer factory, pharmaceutical company, and laboratory depends on these basic concepts. This chapter helps us move from quantitative thinking, qualitative thinking to quantitative thinking. That means what is happening to how much is happening. Without these concepts, chemistry could be guesswork. With them, chemistry becomes a precise, predictive science. This is why this chapter is backbone of physical, organic and inorganic chemistry. To summarize, matter can be classified into pure substances and mixtures. Chemical reactions obey fixed laws. The mole concept allows us to count atoms and molecules. Stoichiometry helps us calculate exact quantities needed for reactions. If you master this chapter, many future topics in chemistry will become much easier. Thank you for your attention. Please revise these concepts carefully, practice numerical problems, and don't hesitate to ask questions in the comment box given below. Once these basics are clear, chemistry becomes logical and enjoyable.